Hello everyone. Welcome to PKS Trainings Brief and Short session where we explain a .NET concept. First, a short introduction of PKS Trainings. We provide market and job specific trainings on basic .NET and advanced programming skill sets. Our trainers have over 15 years of real-time market experience. With that said, let us first understand how VB6 or C++ programs, that is non-.NET applications, used to execute. We know that computers only understand machine level code. Machine level code is also called as native or binary code. So when we execute a VB6 or C++ program, the respective language compiler compiles the respective language source code into the native code, which can then be understood by the underlying operating system and hardware. This process is depicted in the left image. Native code is specific, native to the operating system on which it is generated. If you take this compiled native code and try to run on another operating system, it will fail. So the problem with this style of program execution is that it is not portable from one platform to another. Now let us understand how a .NET program executes. Using .NET, we can create different types of applications. A few of the common types of .NET applications include web, Windows, console, and mobile applications. Irrespective of the type of the application, when you execute any .NET application, the following happens. First, the .NET application gets compiled into intermediate language, IL. It is also referred as Common Intermediate Language, CIL, and Microsoft Intermediate Language, MSIL. The block here, assembly, that is depicted by CIL and MSIL. Both .NET and non-.NET applications generate an assembly. Assemblies have an extension of .dll or .exe. For example, if you compile a Windows or console application, you get a .exe. Whereas when you compile a web or class library project, we get a .dll. The difference between the .NET and non-.NET assembly is that .NET assembly is an intermediate language format, whereas a non-.NET assembly is in native code format. Non-.NET applications can run directly on top of the operating system, whereas .NET applications run on top of a virtual environment called as Common Language Runtime. CLR contains a component called Just-in-Time Compiler, JIT, which will convert the intermediate language into native code which the underlying operating system can understand. So in a .NET, the application execution consists of two steps. The language compiler compiles the source code into intermediate language, IL. The JIT compiler in CLR converts the IL into native code which can then be run on the underlying operating system. This process is shown in the right image. Since a .NET assembly is an intermediate language format and not native code, .NET assemblies are portable to any platform as long as the target platform has the CLR. The target platform's CLR converts the intermediate language into native code that the underlying operating system can understand. Intermediate language is also called as managed code. This is because CLR manages the code that runs inside it. For example, in a VB6 program, the developer is responsible for deallocating the memory consumed by an object. If a programmer forgets to deallocate this memory, we may run into hard to detect out of memory exceptions. On the other hand, a .NET programmer need not worry about deallocating the memory consumed by an object. Automatic memory management, also known as garbage collection, is provided by CLR. Apart from garbage collection, there are several other benefits provided by the CLR, which we will discuss in a later session. Since CLR is managed and executing the IL is also called as managed code. .NET supports different programming languages like C#, VB, J#, and C++. C#, VB, and J# can only generate managed code, that is IL, whereas C++ can generate both managed code and unmanaged code. The unmanaged code, that is the native code, is not stored permanently anywhere. After we close the program, the native code is thrown away. When we execute the program again, the native code gets generated again. .NET program is similar to Java program execution. In Java, we have byte codes and JVM, Java Virtual Machine, whereas in .NET we have intermediate language and CLR, Common Language Runtime. To summarize the points that you should remember, IL is also called as MSIL or CIL or managed code. Assemblies have an extension of .dll or .exe depending on the type of application. .NET assemblies contain IL, whereas pre-.NET assemblies contain native code, that is machine code. In .NET, the application execution consists of two steps, which also offers portability: compilation, source code to IL, and the second step is execution or JIT, just-in-time compilation. Next point to remember is CLR. .NET Runtime environment provides several benefits. Garbage collection is one of them, as we discussed earlier. .NET supports different programming languages like C#, VB, J#, and C++. C#, VB, and J# can only generate managed code, whereas C++ can generate both managed code and unmanaged code. The native code is not stored permanently anywhere. After we close the program, the native code is thrown away. When we execute the program again, the native code gets generated again. That's all